And for our last topic, we have the standard normal distribution. What is the standard normal distribution? Well, as you already know, the Z standardization, it is the way of converting all the values into Z scores. The standard normal distribution, it is a way of using probability or scale other magnitudes into this same uh, real-shaped curve. So what we do here, so the as you already know, the Z scores we got last class. We have these values and I added this. So let's get the Z score first because we want to get this this number will become 0 in Z standardization and standard normal distribution. And now we want to get, so here's 1 and 2 minus 1 minus 2. Key so key characteristics of this table. So the between 1 and minus 1, the 68% of the data will fall between this category. Between this and other will be 95% of the data. 95% of the data will fall within these two categories. And between 3 and minus 3, 98%, 99.7% of the data will fall within the 3 and minus 3. So let's get the Z scores for this this day this given data. And so we x will be 85 minus 70 over 10, that will be equal 85 minus 70 was 15 over 10. What it gives us the Z equals to 0, 1.5. And now, so we have the first result. Now we will find out the second one. In the second one, we have x will be 56. No, 56 minus 17 over 10. 56. We have 4. 10. That will be minus 14 over 10, which gives us minus z prime equals to minus 1.4. So we have the results. Let's use another color for the z and z prime. Z prime. You can call it another letter, but I would like to call it z prime. And so that will be 1.5. That would fall here, and 1.4 negative will be almost like here. So what we want to do now, give me a minute until, well, you have to enter this data in your calculator using a formula. So I'm going to erase part of this and I will put it here. Give me a minute, right? So if you were waiting for this data, let me tell you that there are two ways of calculating the probability. One using a Z table, or the second one using Excel using norm as distribution plus your value. And you get a result that that it is in decimals, that you can convert it into percentage. So here will be 0.08%, and the second one with 93%. Oh, so what it tells that from here all the way back until this part, the whole area under the curve painted, it is 93% of the table. So this value, it tells us that the probability that this to happen is 93%. 93%. It follows in all the graph. Now the 0.3% will be minus 1.14. So let me erase this. I will be careful not to erase the whole thing. And so now 1.14 will be here. Let's use another color for this. It was here and here that here, it was here. It will be here. 1 minus 1.4. And no, it will be here. 1.45, 1.5. So from this part until all the way until the beginning of this curve, bell-shaped curve, that will be 1.5. The probability that this could happen is 92%. Now, the minus 1.4%, 1.4, if you insert in this equation or in a z table, you will get 0.8%. That's the probability of this to happen.